Hey there folks, welcome to Module 5 of the Microsoft MD-100 course. Today's module is titled Configuring Networking. As for the main sections in this specific module, we'll be covering something called Configure IP Network Connectivity. So that's going to be the title of the first section. Then we'll look at Implement Name Resolution, followed by Implement Wireless Network Connectivity, remote access overview, and then lastly, remote management. So those five are the five main sections in this module. That is definitely not all the topics, that's simply the sections of this specific module. If you want to know more accurately what the topics are, you'll be able to find that in a video description down below. Just go have a peek there. Normally there's also timestamps there you can go and use to skip ahead to certain topics if you're looking for something specific. Alright folks, if you haven't done so already, remember to give the video a like. It does help, promote this video so that people can find it more easily on YouTube. And if you'd like to know when the next module comes out, also remember to subscribe to the channel. Alright, let's take a look at that first main section, which is Configure IP Network Connectivity. Now, one of the first topics we're going to be talking about in this section is Windows Network Configuration. So just to give you guys an idea, here's a bit of a picture for you guys. I took this picture in the Settings app. So for those of you guys not familiar with that because maybe you didn't watch the previous modules, that is effectively the new control panel in Windows 10 and Windows 11. Doesn't look the same on Windows 10 and 11, but both of them have a new control panel. Yes, the old one is still there in case you're pondering. Yes, it's still there, but not for much longer. Now, this picture is specifically about, was taken in Windows 10. So if you go into Windows 10, this is what you can expect to find in the Settings app. You can see that on the left-hand side in the picture, they've got Wi-Fi, Ethernet, so that's your network cables, dial-up if you need to go and set that up. Nobody's going to go and do that. VPN, that's something very high in demand for most companies. Airplane mode, so that's more for laptops, that kinds of stuff. Mobile hotspot if you find yourself needing to make one. Data usage and proxy. Now, depending on what build of Windows 10 you're running and depending on how up to date your Windows is, you might not necessarily see all of those tabs on the left hand side. It's really dependent on your build and how up to date your Windows is. So just to give you guys a more or less idea as to where you would find this, let's switch over to a virtual machine I've got running in the background. Alright folks, here we are on that virtual machine I spoke of, the one running in the background. So I'm not exactly sure what build I've got running on here because I haven't checked in ages. I just know it's not the latest build, but it should serve its purpose nonetheless. So how do we get to the new Settings app or, well, the new control panel? So you're going to just do that by clicking here on Start at the bottom left. For Windows 11, it'll obviously be the Start button in the middle. And on Windows 10, you're just going to go here to the little section that says Settings. Sometimes it might just show you the little gear icon. Some people might call it a sprocket. If this is on Windows 11, you're just going to click on the Start button in the middle, and you'll see somewhere here in the vicinity there's going to be a giant icon that says Settings. Potato, potato. Same thing. So doing this on the Windows 10 side of things, I'm going to click on that, which opens what is known as the Settings app. So this is the new control panel. Depending on obviously your build and edition and blah blah blah, you might find additional tiles here. So the one we're looking for today is the one here in the middle, at least on my side it's in the middle. It says Network and Internet. Now once again, depending on your build and update, you might find Network and Internet by right clicking on your network here at the bottom right. So for some of you guys, it might be a little computer icon if you've got a network cable plugged in. For some of you folks, it might be a little Wi-Fi icon of little Wi-Fi bars. Same thing. So if I right click there, I think mine's still the old one that says Open Network and Sharing Center. But if you were to go and do this on the newer builds of Windows 10 and Windows 11, it doesn't say Open Network and Sharing Center anymore. It actually says Network and Internet now. If you click on Network and Internet there at the bottom right, it actually just opens this little section like so. Pretty much the same story. Now what you guys are going to notice on your machines, obviously, once again, depending on how up to date it is, you will find additional tabs here on the left hand side. I mean, for example, just off the bat, off the top of my head, I see things missing, like Wi-Fi, for instance, is missing. It's easily twice as many tabs, that's here. So for now, the purpose of this is just to show you more or less where you would find these options. And where I found them was in the new control panel, which is known as the settings app. You can get to that by right clicking on your little network at the bottom right, clicking on network and internet, assuming you've got a relatively new build, or you can just go to start, click on settings, go to network and internet, and that should take you to this little section where you guys are going to find obviously way more tabs than what I've got here. I mean, heck, depending on when you guys are watching this, they might have even added more tabs by then because Microsoft is continuously changing this. Anyway, guys, so when it comes to your settings for network, that brings us to our next topic, which is overview of IP version 4 settings. That is easily probably one of the most common kinds of settings you guys are going to configure when it comes to networking. Everybody that is in IT needs to know what an IP address is, especially an IP version 4 address, and you need to know the different kinds of IP version 4 addresses you get. Public, private, static, dynamic, APIPA, loopback, you name it. You need to know them all, and you need to know how to configure them and where to go and configure them. So yeah, speaking of IP version 4 settings, so an IP version 4 address identifies a computer to other computers on the network. So what we're basically saying here is it allows it allows other computers on the network to basically know where to find your machine on the network. Assuming this is a computer, it might not even be a computer, mind you. It could be a phone, it could be a tablet, it can be a printer, it can be a scanner, it can be an access point, it can be a router. It can pretty much be anything that can connect to a network. Anything that can have an IP address can pretty much, find itself on a network or find something else on the network. So it helps other devices, not necessarily computers, devices find your device on the network. Think of it as, if I have to thumb suck it, think of it as your home's address. If you're going to invite me over, for a cup of coffee or a cup of tea, how am I going to know how to get to your house? You're going to have to give me an address. And once you've given me that address, a house number, a street address, a suburb, a town, you name it, I'm going to use that to find your house. I'm going to punch it into the GPS basically. Same story with computers, except they use IP addresses for that. Now, speaking of IP addresses, we just mentioned quite a bunch of them. Something you guys need to know, and at least that's the next topic up, is static IPs, which are also known as fixed IPs, versus dynamic IPs. What are these, and what is the difference between them, and how and where do we actually go and configure them? So we're going to show you guys that in just a second. So first of all, the first one there, static IP, or also known as a fixed IP. That is when you or someone goes into a device, like a computer, and you go and manually go and configure that IP address. When you or someone does that, that IP will stay like that until you or someone goes and changes it one day. Thus the name, static or fixed. A dynamic IP is, well, that's actually the default on most devices, including computers and laptops and desktops and all that kinds of stuff. So that is the default. That means your computer doesn't actually have an IP address in the beginning. And as soon as you turn that machine on, assuming it's connected to a Wi-Fi or a network cable, it is going to ask for one. So if the device was already on and it just wasn't connected to the network, it probably doesn't have one. And as soon as you connect it to a hotspot, in other words, a Wi-Fi frequency of some kind, or as soon as you plug in a network cable, your PC is going to try and get an IP address. It's going to do a broadcast of sorts, and it's going to say, basically in a nutshell, hello, is there a DHCP server out there? And if there is one on the network, this could be, built into a router of some kind. Some people pronounce it as router. It can be an actual full-blown DHCP server. So potato, the point is, if there is a DHCP on a network of some kind, it will get that broadcast of your device, probably your computer, and it is going to say, okay, cool, I am here. I've got an IP for you. How about this one? It's going to offer your PC an IP address that's within its scope, assuming there's one available. Your PC is going to get that offer. It's going to say, okay, cool, I like that. I want that. And it's going to send that back to the server and say, okay, cool, I want that. And then once the server receives the confirmation, it is actually going to go ahead and dish out that IP address. So there's 4 steps involved in that. If you'd like to know more about that, we are going to cover a little bit more about DHCP later in this course. Not in this specific module, obviously. There are other videos on my channel and other courses where you can actually go and check that out, where I've actually explained that in great detail. I mean, for example, If you go and check in my Networking Plus course, there's a video that says DHCP explained. And in there, I actually go, full out, in a lot of detail of animations where I explain exactly what a DHCP is, the different kinds you get, how to configure them, where to configure them, you name it. It is all in that video, short and sweet, straight to the point. If you'd like to know more about DHCP, feel free to go and check out that video. So, where do I actually go and configure a static IP and a dynamic IP? So to explain that, we're going to quickly circle back to that virtual machine of mine. All right, folks, here we are back on that virtual machine. So what we want to achieve here is we want to ultimately get to Networking Sharing Center. Now, fortunately, in my case, if I just right click here, I can actually already see Networking Sharing Center. In your case, it might just say Networking Internet. And, it might actually take you to, let me just go back there, Networking Internet. It might take you here first, and you might have to go click on Wi-Fi or Ethernet, depending on what you're actually using. So in my case, I'm going to pretend it's an Ethernet cable. And you might have to go here. No, it's not there. Adapter settings. And you're going to have to go and change it. I mean, there you go. There's Networking Sharing Center. You can actually get to it from here as well. It might look somewhat different to you, obviously. It depends on the build and all that. So, but somewhere around here, you should find a link that says Networking Sharing Center. Now, what I've noticed on the newer builds and versions of Windows 10, it's actually no longer a blue hyperlink in my case, like you would see here. It's actually a little button. I actually like the new button. Normally, when Microsoft goes ahead and changes stuff, I don't, normally like it much, but I like the new button that they've added. So here we don't see a button, we just see a link, so that's the older way of seeing it. By the time you do this, it might not even be a button. It might be something else. They keep changing it. So just go look for something that says Networking Sharing Center. Once you found it, it should look fairly much the same as mine. So you can see I've got a cable plugged in here, pretend. Could be a Wi-Fi signal. I'm going to go ahead and click on that little bugger. Open that up. You're going to go away here to where it says properties. Click on that. And what we were looking for is IP version 4. Now, depending on how long you folks have been in IT, you would have noticed at some point in time they actually added IP version 6, which is not the topic in today's module. That got added roughly around towards end of 2008, beginning of 2009, when they released Windows Vista or Vista, depending on how you want to pronounce that. Up until Windows XP, we only had IP version 4. So yeah, more on IP version 6 later. So for now, there's IP version 4. You want to go click here where it says properties. And that's pretty much as default as it gets, folks. That option there that says obtain an IP address automatically, and you will notice my blocks are blank here, that is considered a dynamic IP address. Well, it's dynamic, the setting at least. I don't necessarily have a dynamic IP yet, because I have to actually get one from a DHCP to, call it a dynamic IP address. So the point is, if you're on that option, my machine is going to go and request one, assuming you can actually contact the DHCP. And if it's able to get a hold of one, I'm going to have a dynamic IP address. If you were to go ahead and click on this option there, that is considered static or fixed. And now you or whoever is doing this will have to go and actually type in an IP address. It's not always as simple as just typing in a random IP address. No. If you're going to be doing this in an existing environment, you or whoever is doing this will have to go and check out what the IP range is in that network, the network ID in other words. You will have to go and check it out. So it's not a matter of just willy-nilly thumb sucking it and typing in a random IP. You will have to go and check what range they're using. So for argument's sake, if everybody is using 192.168.0, you will have to go and type in 192.168.0, and then only the last digit, which we call the last octet, will be different for you and your device versus the other devices. So the first block there, that's obviously the IP address. I mean, it kind of says it there. Subnet mask, something we're going to look into in just a moment in a slide or two. That basically, in a nutshell, just allows you to go and subdivide your network into multiple networks. Some of these networks have limited amounts of IP addresses. I suppose you could use it for security, but it's not really intended for that. It's more for, managing your networks if you want to go and organize them and subdivide them into categories. The default gateway, you'll notice, is very much the same as your IP address. It's just the last octet that changes. Most commonly, that last octet, the number is probably going to be 1. It's not set in stone, but normally as a best practice, we tend to make that 1. So the default gateway is the device you or this person or this device needs to go through to get to the outside world, in other words, the internet, or to get into another network. So if you happen to have more than one network in your company because you did something called subnetting, the default gateway, which is probably going to be a router, is the device you need to go through to get to the other networks, which is probably going to be a router then. If you want to go to the outside world, in other words, the internet, which is a more common scenario, the default gateway would be the first device you or this device needs to go through to get to the outside world. So if this is a home environment or a small office environment, the default gateway is realistically probably going to be your router, and that's that. If this is a medium to large size organization, yes, there's going to be a router, and ultimately you are going to go through the router to get to the outside world, but it's not necessarily the first device you would be going through. In the real life situation, you'd probably be going through something like a firewall first. Not something you guys need to know for this course, not something you need to know for the exam. I'm simply putting that in there as an extra for you guys, giving you guys a little bit of real life experience. From an exams perspective and from the scores perspective, you just need to know the default gateway is the router, and that's the device you need to go through to get to another network or to get to the outside world. That's all you need to know for the exam. But in real life, I can tell you it's much more than that, and it gets much deeper than that. In real life, it's not necessarily going to be just a router. It's going to be a matter of there's probably going to be a firewall, and that first device you're going to hit before you hit the router is going to be a firewall. So that default gateway IP, guess what that's going to be? That's going to be the IP of the firewall because that's the first device you go through. Now, as for DNS, not something we're really going to cover too much in this specific module, but that basically stands for domain name server or domain name service, depending on how you want to look at that. And it's ultimately a server that converts names to IPs and IPs to names in a nutshell. Definitely not the only thing it does, but in a nutshell, that's what it does. So if you, for example, want to go to a website like Facebook or YouTube.com, you're going to go and type in something user-friendly, easy peasy that you as a human can understand, something like www.youtube.com. Your computer is going to see that, and it doesn't actually know where that is or what that is. It's going to go and ask this server called the DNS server, what the heck is this? Where the heck is that? And the DNS server is going to go and look up something called a record. And in that record, it's going to find the IP address for YouTube, which basically tells your machine where the heck it needs to go on the internet. You can think of it as GPS coordinates if you want to call it something. There is DNS servers. They can be both on premises as well as online, I suppose you can call it on the internet. So something that's very much used by most folks, including myself, is just to go and use good old-fashioned Google. If you want to use Google as the DNS, that will be 8888, so it's literally just 48. And they've got a second, address, which is 8844, so it's 8844. You don't have to know that for the exam. You don't need to know that for the course. That's just food for thought. In case you would like to go and configure the DNS. There are some companies out there that like to go and use their own DNS, but that's getting more and more rare by the day. Anyway, folks, let's circle back to that slide. I was talking about subnetting here anyway, so I believe that is actually the next subtopic if you want to go and call it something. So next up, we have something called defining subnets. So we're having a kind of sort of idea. We know it's a way of dividing your networks into subnetworks if you want to go and call it something. So a subnet specifies which part of an IP version 4 address is the network ID and which part is the host ID. At least that's one of the things it does. It's not the only thing. So here's an example of a random IP address, 192.168.2.15. And here's an example of a random, pretty standard, pretty common subnet mask, 222.55.0. So network ID is the part that's going to basically be the same for everyone or everything on this specific network. Now, if you look at that subnet mask, being 222.55.0. Now, if you see 3255s, that's first of all considered a Class C network, not something you need to know at this point in time. And it basically means the first 3 octets of an IP address will be the same for everyone and everything. If I saw 255s there, only the first 2 octets were 255 and the last 2 were something random, that would mean it's a Class B network and only the first 2 octets of every IP address needs to be the same for everyone and everything. And if only the first octet in the subnet mask was 255 and the last 3 were random things, you can probably guess what that's going to be. It's a Class A network. Only the first octet in the IP address needs to be the same for everyone. Now, in case you're wondering, yes, you get a class D as well, but that's experimental. We don't talk about that. All you need to know is it's experimental, it's called class D, and that's that. They won't ask you any questions about that in the exam. I doubt they're going to ask any questions about class A, B, and C even in this specific exam, since this exam is not about networking, it's about Windows 10 and it's about Windows 11 in general. So getting back to the example I've got here for you guys right now, being 22255.0, that means it's class C. That means the first 3 octets will be the same for everyone. So what is my network ID? In this case, my network ID is 192.168.2. Yeah, I added a 0 there, but you can ignore that. So it's basically the 192.168.2. That is my network ID. That is what's going to be the same for everyone on this specific network. Now, also speaking about defining subnets and all that, something that I've already explained to you guys, so just to sound like a broken record, a default gateway is a device, which is usually a router, but you guys know better, it could possibly be a firewall as well, on a TCP IP internet network that forwards IP packets to other subnets. Yeah, generally, it forwards it to other subnets, but it's not limited to that. This can also be a matter of to forward your packets to the outside world, being the internet. So the default gateway is basically the device you must go through to get to another subnet or the outside world. And we know in most cases it's going to be the outside world, of course. Now, another topic I've got for you guys, since we're talking about subnetting and IP addresses and all that, is public IPs and private IPs. We did mention that a little while ago, not too long ago. So we know it's IP addresses, but what the heck is this? Where do we see this? Where do we use this? And where do we configure that? So what I'm going to do is I'm going to start you guys off by giving you 3 computers here. I want you guys to basically imagine this as the inside of your home, the inside of your office. It's not up to scale. I know realistically in real life, you guys probably have, possibly hundreds, if not thousands of computers in your environment. So it is not up to scale, but it's fine. It should serve its purpose. So this is maybe 3 random devices in your big environment at your office. It could even be your house. It doesn't really matter. So there's my 3 computers. What I'm also going to add here for you guys is something here in the middle, and I guess you guys probably know what that is. That is a router. It's not an access point, it's a router. And that is going to basically allow these 3 computers, or however many you might have in your environment, to access the outside world. Yep, that's what we're about to do here. And since we're talking about the outside world, what I'm going to add here on the right is a little globe. That's just to help you guys visualize this as a visual aid. So you can imagine that as being the internet. So since we're talking about the inside and the outside world and the internet and all that, what I'm going to do is on the left side of this router, we're going to call that the inside of your network, obviously, because that's where my computers are. On the right hand side here, we're going to call that the outside of a network. So that's the outside world, it's an outside network. Left side, inside world, inside network. Now, the inside part of your network, the part inside your house or inside your office, that is private. So we'll add that little note here. And obviously the outside, that is public. So what we're also going to do here is we're going to give everything an IP address, for the most part. So I'm going to start off with these 3 machines we've got on the left hand side. Let's give them IP addresses. The first one will be 192.168.0.4. The second one will be at .5. And the third one, well, .6. And then, just for good measure, we'll give this router here in the middle an IP as well. And like I said, the router, being your default gateway, is usually going to be a .1. So we're going to make that a .1. You can ignore the /24 there. That's just a side notation to show us the subnet mask is 22255.0. And this is a class C network. That's basically what that means. Not something you need to know. And I'm going to go and thumbsuck it and give this globe a random IP. So that IP we see there is a public IP on the right hand side. The ones we see on the left, which is the inside of your network, those ones right above your computers, those are private IP addresses. Any IP address on the inside of your home or the inside of your company or your office are seen as private IPs. As soon as you or someone or something goes out to the outside world through the router to the internet, in other words, that is a public IP address. Now you might say, hey, but I've got a dynamic IP, or hey, I've got a static or a fixed IP. It doesn't matter. It doesn't matter whether you or someone went and configured a static or a fixed IP on that device. It doesn't matter whether that device got a dynamic IP from a DHCP, of some kind. It doesn't matter if that DHCP is on a router or a server. It doesn't matter. Any IP, whether it's static or dynamic, on the inside of your network is seen as a private IP address. And as soon as you go out to the outside world, that IP is now a public IP. This might sound a bit confusing, but what a lot of people don't realize is when you or something has an IP address on the inside, yes, we know it's private. As soon as you go through that router, it gives you a public IP address, or it's a public IP address. So you're not going to see the same IP. So if you're going to go and check what your IP address is on the inside of your network, you'll see one IP address. And as soon as you go into the internet, some websites will actually show you what your IP address is. I mean, heck, you can even go to Google and say, what's my IP? You can actually go and try that right now, and it's going to show you what your current public IP address is. Interesting, right? Now, IP addresses on the inside of your network, whether they be dynamic or static, you've got control over that. If it's a static IP, you or someone can go and manually configure it. Now, you might say, but what if it's a dynamic IP? Well, someone has to configure that DHCP, either you or the IT team, so whether it be on the router or the server, someone still has control over that. Now, as soon as you go through the router to the outside world, you don't have control exactly over what IP address you get. Your ISP, in other words, your internet service provider, will issue you what we call a public IP address. Everyone on the inside of the network has their own unique private IP, but as soon as everything goes through that router, they will all share the same public IP address. So there's both benefits to this and drawbacks. I mean, so on the inside, if one of these guys goes into a website of some kind and they do something naughty, that person won't just get themselves blocked, they will get everyone else blocked that's sharing that same public IP. Kind of reminds me in school where one kid wouldn't do his homework, and the teacher will be like, okay, guys, he didn't do his homework, you're all going to get extra homework. Kind of reminds me of that if you think about it. Alright, so that basically concludes the public and the private IP addressing side of things. Let's move on to our next main section. Yeah, now we're only getting to the second main section, which is implement name resolution. So basically, in a nutshell, this is all about DNS. It's a summary of DNS, is actually what it is. Alright, so let's start at the beginning again. First of all, what is name resolution? So this is basically something that's going to take place when you or a company has something called a DNS server. Nowadays, like I said earlier in the previous section, DNS service is not something you would necessarily find on premises, at the office. This could very well be online, like Google. A lot of people, including myself, like to go and use Google because, those DNS servers are way more secure. They've got way more records. It's just better in so many ways. So we've established earlier in the previous section that DNS basically in a nutshell converts IPs to names and names to IPs. So when you go and grab a computer and you go and type in a URL, in other words, a web address like www.youtube.com, your computer doesn't actually know what that is or where that is. So it's going to go and contact something called the DNS server. It's going to basically say, hey, bro, what the heck is this? Where the heck is this? And the DNS is going to go and do something called lookup. It's going to go and look up a record. It's got a very large repository of records. You can think of them as little files. It's going to go look up one called the YouTube record, for lack of a better description. And eventually, when it finds this record, being the YouTube record, it's going to open it up. And it's going to see what the IP address for YouTube actually is. Once it gets that, it's going to give that IP address to your machine, and your machine would ultimately know where it needs to go. And if I have to compare this to something totally random in real life that I'm thinking about right now, it's kind of like a GPS. Not exactly, I know it's not the best example, but it's kind of. I mean, if I tell you guys to come to my office or my home, you're not going to know where it is. I'm going to have to give you guys an address. And if you haven't been there before, you're going to probably punch in that into a GPS of some sort. Your GPS is going to guide you on how to get to that location. Now, once you've been to that location at least once, the chances are you might be able to get there the second time without actually using a GPS because of your short-term memory. So the next day, if I ask you guys, hey, come back here, you're probably going to be able to find it because you remember more or less how to get there. Now, believe it or not, computers actually work in the same way. So the first time they need to go to a website, they have no cooking clue how to get there. And they're going to go and ask the GPS, GPS, I mean DNS, which is like a GPS, and it's going to basically use those instructions, that IP address, to find the location it needs to go to. And once your PC or your device has been to that website at least once, in this case being YouTube, it will remember what the IP address was for that particular site. It's called the cache, or the DNS cache to be more precise. And just like a human being, I mean, if you've been to my house or my office, you know where it is. But if a few months has gone by, 6 months, 12 months, or whatever, there's going to be a certain point in time where you're going to forget how to get there. And you're going to have to go and, punch it all over again into the GPS just to remind yourself. Computers work the same way. They eventually forget how to get to a website. And when that happens, not if, but when, it's going to ask the DNS all over again, hey, bro, where is this? And the DNS is going to basically guide it and give it that record again. So I might have gone too far here, but at least now you've got a more or less idea what a name resolution solution is. Alright, so just to recap, overview of DNS, I'm going to dump a little CPC here for you guys at the bottom. So there we go. And just like we explained on this little computer there, I'm going to go and type in www.youtube.com. It doesn't know where that is. It's going to go and ask something called the DNS server. So there's a DNS server at the top. And the DNS server is basically going to tell that little computer where YouTube is or how to get to YouTube. In other words, it's going to give it the IP address of YouTube. That's what it is in a nutshell, guys. Now, speaking about DNS, we've said quite a lot of things about DNS. Just like anything else, DNS is bound to eventually encounter some sort of issue, and there's way too many I can, to mention in this specific module. If you'd like to know more about that, heck, you're welcome to drop a comment down below and ask me, and I'll gladly reply on your comment and just tell you about some of these things and the steps you can actually go and take. Heck, if you're experiencing a current problem right now, feel free to drop it down below and I'll see if I can help you. Anyway, so when it comes to troubleshooting name resolution, one of the first things you can go and try is to clear the DNS resolver cache. This is generally done by typing in something called ipconfig/flush DNS. You would remember I said earlier, if you've been to a website previously in the last, few days, few weeks, let's just say recently, your computer is going to remember where that was because of its short-term memory. That is called your DNS cache. And if you want to force your computer to basically forget or the address for a certain website, you can go and do something called ipconfig flush DNS. It's not something we normally find ourselves doing, and it's very rare you're going to have to do this. But to give you guys an example of when and why you might want to go and do this, imagine for a moment someone or something did something called DNS poisoning. What that basically means is someone went and tampered with the DNS records on your DNS server, and when your PC goes and asks the DNS, hey bro, where is this place called youtube.com? DNS server is going to go and look up that record like usual. It's going to get the IP address like usual, except that IP address that it's going to get doesn't actually belong to YouTube. It belongs to some other website, most likely a phishing website that looks exactly like YouTube to get you to click on the wrong link or to type in your details, your login details. So that's basically an example of DNS poisoning. So now if you're going to go and let's say fix the DNS server afterwards, let's say you actually went and fixed the DNS server, that doesn't automatically mean all those PCs that went to the wrong website are fixed now, because they still remember the old IP, the wrong IP. So you're going to have to first fix the main issue, being your DNS server. Once you fix that, you will need to go and force all these computers to forget their short-term memory. Forget the cache. Clear the cache, in other words. Anyway, getting back to the main agenda here, something else you guys can go and do is verify connectivity to the remote host by using the IP address. So this is now assuming there's not poisoning that's been taking place. Maybe there's just some sort of issue of the DNS server in general. You can also go and try and verify connectivity to the remote host by using its name. Any device, PC or otherwise on a network can normally be reached, assuming everything's working correctly, of course, by typing in its IP address or its name. So by trying one or the other, then at least this can help you identify if it's an IP address issue or a name issue or what else it might be. So anyway, if those are unsuccessful, if the test is unsuccessful, edit the host text file. Just see if that doesn't resolve it. And then obviously just go and repeat step 3, which is now, going to probably solve your problem most likely. Right, folks, so that brings us to the third main section in this module, which is implement wireless network connectivity. So when it comes to wireless connectivity, I think everyone pretty much knows what wireless means these days. It's just a matter of you might not know what the actual hardware looks like that actually broadcasts that signal, from a company's perspective. So most modern networks these days are pretty much a combination of wired and wireless networks. Wired basically means network cables. So when you go to the office, you'd find there's normally some sort of network cable, which you guys might more commonly known as a LAN cable or a Cat5, Cat6 cable. You plug that into your laptop or your desktop, and there you go. You're on the network. Now, what you'll also find is most of these company networks also have wireless. So they've got access points, or in some cases, the router itself will broadcast signals wirelessly. And this allows you and your colleagues to connect to the network using your phones, your tablets, your laptops, and pretty much anything that's able to receive a wireless signal. So to give you guys an idea, here's a picture for you guys. And in this picture, if you look at the left there, I've got two desktop computers there at the bottom left. The little triangle there is, if I have to thumb sucker, that's a switch of some kind. It doesn't always look like that. It's not the best picture, but hey, it's a picture. So there I've got two computers connected to one another using a switch. And at the same time, from that switch, there's a cable that goes to a little round blue circle at the top. That is the router that allows me to get to the outside world or different subnets. From that router, you can see above it, there we've got a little Earth globe there. Obviously, that represents the internet as we know it. And then from that switch, being the little gray triangle towards the right, we'll see another little circle. That, guys, is an access point. Access points are also known as APs for short, access point. And that basically just takes the exact same network and simply just goes and broadcasts it wirelessly. There's many frequencies we can go and broadcast in. Not going to go into too much depth with that in this specific module. But the most common frequencies you would find being broadcasted in the average home or office building is 802.11g, and the other one is 802.11a. Those two, they're pretty much for the most part identical. It's just the frequency itself that differs. The G one is at 2.4 gigahertz, which is the most common one, and the A one is at 5 gigahertz, which is more like a backup one in case there's a conflict of some kind with the first one. Now, when it comes to configuring Wi-Fi settings and profiles, here I've got a bunch of pictures for you guys that you guys can go have a look at. The one on the left, you can see there I went into the settings app, where it showed you guys earlier on that virtual machine. I went to the settings app, I went to network and internet, and you can see there I've actually got a Wi-Fi tab. How about that? If you go there to the Wi-Fi tab, you may see one or you might see many wireless networks. And there you can go and obviously go and click on one of your choice and try and connect to it, assuming you know the password. In most cases, it's going to ask you for a password. And if you look at the picture on the right there, that's more or less what you can encounter. So if you are on something like a laptop, could be a tablet, but it's probably going to be a laptop, and you click on the little Wi-Fi bars, assuming there are networks in your area, they will be listed there, and you can actually see how strong the signal are. So when you've got like 4 or 5 little full bars there, it normally means it's very close by. That access point or that router is broadcasting nearby. If you see hardly any stripes, that normally means it's a very poor signal because the device that's broadcasting is obviously very far away. Alright guys, and that brings us to another main section here, which is remote access overview. So the topic we're going to be talking about in the remote access overview section is VPN. So more specifically, an overview of VPN. So let's start at the beginning of this topic. What is a VPN connection? I assumed you guys would probably know it's a connection since this whole thing is about remote access and all that. So VPN, first of all, is short for Virtual Private Network. So VPN is an abbreviation. It allows someone to remotely connect to work from home. That's the main goal here, and that's the main thing people use it for. And I think, I could be wrong here, I think that's what it is actually designed to go and do, is to allow people to work from home and connect to some place like the office. It's absolutely not the only thing we use it for these days. People use VPNs for all kinds of shenanigans, including illegal activity. If they want to go and do something not so nice online, you can go and use a VPN connection to basically prevent people from, well, in a nutshell, tracing you. That's one of the things they can actually do. So, but its ultimate goal originally was to give someone the ability to stay at home and connect from a PC or a device of some sort, like a laptop or a desktop, from home to the office securely and remotely. So speaking of secure, it is an encrypted connection. I'm not going to go into the encryption side of things, but there's basically 4 kinds of encryption you can actually go and choose. Now, to help, explain this whole concept of what VPN is and how it actually works, so as a visual aid, if you will, I'm going to give you guys a bit of a picture at the bottom, or at least I'm going to try. So at the bottom right here, what we have there is a normal office environment. You'll see I've got a bunch of PCs there. It's not up to scale, definitely not. I've got about, how many do I have there? 8. So I've got 8 PCs, and at the bottom left there, I've got a little server there. So, this is not up to scale. It could be hundreds, could be thousands of computers in your environment. So for now, humor me and pretend like that's your office. So in your office environment, there'll obviously be many computers, laptops, desktops, and servers. And when you are at the office, we can pretend this machine here, that one that I'm circling for you guys, that one, we can pretend that's you for a moment. And when you are at the office of your laptop or desktop, generally speaking, you've got access to all of your colleagues. So you can go and access them. If you run a search for their computer's name or their computer's IP address, you should be able to find them on the network. If you try to access the server there, or servers, it could be more than one. If you try to access that on a network, you'll be able to find it. Why? Because you're on the same network. You're in the same building. So whether you're on a cable or the same Wi-Fi, you are in the same network. So now I'm going to give you guys a scenario. So we're going to start moving into the VPN topic. Imagine for a moment, I'm going to remove you guys out of that network now. So there you are. You're missing. And I'm going to put you here way on the left in a block called home. So now you are at home. Why? We don't know. This could be for any reason. Maybe you have tested positive for COVID-19 and your office doesn't exactly feel comfortable of you being at the office. Yet they want you to work, or you would like to do your work. And well, now you're stuck at home. So you've got a laptop or a company desktop. You're sitting at home and you're turning that little bugger on and you're trying to access your colleagues at work. Can you still access them on their IP address or their computer names? No, because you're not on the same network. You are on your home network. Can you access the server at the office? No, you cannot, because you are on your home network. It's an entirely different network. Now, how do we get around this scenario? We're going to use something called VPN. So VPN, we know it's a remote connection. It allows you to connect from some place like home in this situation back to the office. So you can be at home, you can connect back to the office, and if and when I do that, it's basically like digitally teleporting yourself to the office. Even though you are physically sitting at home, your laptop or your desktop is physically at home right in front of you, it's almost as if you're at the office. It's as if you're sitting in the office at your desk and you're plugged into a network cable there, or you're on a hotspot at the office. It's exactly like that. Anything and everything you could normally do while you were sitting in the office, you can do that now. As soon as you VPN to the office, it's like digitally teleporting yourself to the office. Anything you could normally do, you can now do. Anything you can normally not do also applies now. So all policies, rules, and procedures that would normally apply, good and bad, will apply to you and they get forced down upon you. So if there's a policy at the office that says you're not allowed to do certain things or allowed to access certain things, guess what? That's going to kick in until you disconnect from that VPN connection. So that's basically what VPN is in a nutshell. Now, speaking of disconnecting, it reminds me, you're probably going to have to go and connect to it. So before you can actually go and connect to a VPN connection, someone, which is probably going to be you guys one day, will have to actually go and set up a VPN server. That is not part of this module, and it's quite frankly not even part of this specific course. But from the client's perspective, you guys will need to know how to go and set up a VPN connection. This can be done one of 2 ways. The first way, and the most common way, is to go into the settings app, like I showed you guys earlier. Go to network and internet. Once you go to network and internet, you're going to go click on the VPN tab. And once you click on the VPN tab, you guys are ultimately going to go and see this little window that I've got open for you guys. Now, completing this window is actually pretty straightforward. I mean, you can just go and type in any name there where it says connection name. I like to just go and type in something like the office. If it's yourself, you can be creative, but you need to keep in mind you are probably going to be setting this up for one of your users or one of your clients. And 9 out of 10 times, these folks have no clue what they're doing when it comes to IT. So if you're going to tell these people, sir, ma'am, you need to go and start your VPN connection first before you can access the resources of the office. They will have absolutely no clue what you're talking about. When you tell them, ma'am, sir, when you use your VPN connection, you are basically remote connecting to the office. You're going to confuse the daylights out of those folks. So it's best they don't know. I would say just tell them, you know what, before you start working, just start this connection, that's it. The less they know, the better in most cases. Keep it simple, call it something like the office so they at least know what it is. The server address, I can't tell you what that is, but normally we can actually guess it. In most cases, it's the company's name followed by .vpn or VPN followed by the company's name. In my case, I just made up my own company name. They're called BurningIceTech. So 9 out of 10 times, that's what the company's server address is going to be. It's not a state secret. You can actually guess that, like I said. So what's going to keep people out of your company's VPN connection is usually the usernames and passwords. Funny enough, most companies only use usernames and passwords and they have no additional security. It's of utmost importance that you go and add additional security to this because, like we said earlier, if you VPN to the office, it's as if you're at the office. So can you imagine some complete stranger out there, like a criminal, a hacker of some kind, is able to guess the username and password or crack this to your VPN connection? It's as if they literally strolled into your company, plugged in a laptop into your network. Can you imagine the level of damage they can do? And not only did they plug themselves into your network now, they actually have an account. Can you imagine the damage they can do? So the more security you add on to this, the better. So my suggestion is use MFA, multi-factor authentication, which means this person that's about to connect needs to prove in more than one way they are in fact who they say they are. So never mind using a password and username, they might have to go and provide an OTP, a one-time PIN they will receive on their phone, or something else, something similar to that. I would also recommend maybe using a certificate. So this basically means it's a file that gets installed on a person's device, and when that has happened or taken place, that username and that password of that specific user can only be used on that specific machine. So even if they were to give the password on a piece of paper to a friend of theirs, it doesn't mean jack squat if they don't have that certificate installed on devices. This doesn't make it impossible for people to break into your VPN connection. You simply are making it so much harder and you're just trying to discourage bad behavior. No security you add to anything in life is ever going to keep these hackers out. All we want to achieve here is we just want to make it so darn gosh inconvenient to the point where you're going to annoy them and they're just going to give up and go to the next company. That's all we want to achieve. Now, anyway, speaking about remote connections, that brings us to our last main section, which is also about remote connectivity. This one's called remote management. So in this section, we're going to talk about, I think, two things. The first of which is remote desktop. So overview of remote desktop. So I'm going to go and drop two pictures for you guys. Here's the first one. So that's probably what you guys will be familiar with if you've ever seen remote desktop or used remote desktop. What does it actually do? It allows you to remote connect from one machine to another using this platform called remote desktop. Now, the PC you are connecting from, nothing really needs to be configured. You're just going to go and open remote desktop and you type in a destination's name or its IP address. This can be a computer or it can be a server. That's it. On the destination machine that you are connecting to, whether it be a server or a computer, you will need to go and allow remote desktop through the firewall, the Windows firewall, because it's normally blocked by default. And you will need to go and turn on remote desktop because it's also turned off by default. You might wonder, but why the heck would they go and block that by default and turn it off by default? It's for the average user's own safety and security. Not everybody is an IT like you guys. So if remote desktop was turned on by default and allowed by default for everybody, that would obviously be a huge security risk. And other people like us, that's an IT that's not always nice like you guys, those guys can take advantage of those people that have no clue what they're doing. Not so nice, right? So there is one place you guys will actually find remote desktop allowed by default and turned on by default, and that's for virtual machines, virtual client computers and virtual servers that's running in a cloud. So if you look at something like Microsoft Azure, yes, you can go and make virtual machines on Azure if you know what a virtual machine is. And by default, the way we connect to those machines is using something called remote desktop, which is this topic. And if I just install Windows on one of those machines, I cannot exactly go and turn on remote desktop, initially. It needs to be turned on, right off the bat so I can connect to it the first time. It's the only place you will find it turned on and allowed by default. If it's a physical computer, server or client, if it's a virtual computer on premises, it's normally blocked. It's normally turned off by default. Now, when you connect to a remote machine, this can be a server or a client, like I said, You can actually go and click there at the bottom left on that little window where it says show options, and you would see this window. You'll notice there's a whole bunch of tabs there. My favorite, of course, being this one in the middle. It says local resources. And what this allows you to do is you can go and actually go and fiddle these settings. You can go and choose, for example, where audio plays. So if you look at that one there, it says remote audio. You remember, you are connecting to a remote machine. So using that option, you can go and choose where sound plays. So if you're going to go and open a web browser on this remote computer, and let's say you go to YouTube to go listen to a music video of some kind, where did the audio actually play? Does it play on the remote device, or does it play on your side? You get to choose that. If you want to go and record audio, where does it record? Does it record from your machine, or does it not record at all? As far as I remember, I have to go and double check it. There's not an option that allows you to record from the remote machine, because that would technically be seen as a form of hacking. Now, looking at the bottom section there, that says local devices and resources. You'll see there's two little tick boxes there. It says printers and clipboard. And if you were to go click there on the more button, you guys can go check that out on your own if you want to. This should be available on pretty much most machines. You can actually go and pull resources through this remote session with you. So if you have a local hard drive on your local PC that's got certain resources, you can go there to more, you can go and tick that hard drive, and when you connect to a remote PC, you can actually access your local hard drive on the remote PC as if your local hard drive is part of that remote PC. Keeping in mind, of course, you are doing this over the network, which means there might be a bit of a lag or a delay when you access those files. How much depends obviously on how fast your network is and how big those files are. Now, when you do remote desktop session, generally, there's can only be one session to one remote PC, especially if it's a client PC like Windows 10 or 11. If you're going to do it to a server, also generally only one session, but servers do give you the ability to go and have multiple remote desktop sessions. That does, as soon as you go more than one, it's going to start asking you for licenses for, we call those CALs, CALs, which stands for Client Access Licenses. Basically, this means you're going to need a license for each and every remote desktop session then. Not something you need to worry about at this point in time. It's not part of the course. It's not part of the exam. You just need to know what remote desktop is. Now, if you're going to go remote desktop to someone's computer, someone that's already logged on to the computer, it will kick them out of their PC to the logon screen where they would normally have to type in their Windows password. And you can now go and take full control over their machine. Should they go and log back in, it'll kick you back out, and vice versa. So only one person can see that machine at a given time. Now, the next topic here, which is remote assistance, slightly different. So first of all, here's a little picture for you guys so you can see what it would look like once you run this. So when you run remote assistance, the name actually says everything about it. It's to give you remote assistance. Now, not even Microsoft uses remote assistance. The last time I've seen someone use this, well, I think was in 2008 when Vista just came out. Not even Microsoft uses that. They use third-party tools like TeamViewer. Can you believe it? Now, the idea here initially was if you are the person in need of some sort of technical assistance, you would go onto your computer, open this magical beast called remote assistance, and you would go and create something called an invite file. It's a tiny, tiny little file, and the goal here is for you to send that to the person that needs to assist you remotely. You're going to probably send it via email most commonly. And as soon as they get that file, they will click it, and it's going to open a remote session from their machine to your machine. So what does remote assistance enable you to do? It allows you to view remote desktop. This is now assuming you are that technician giving assistance. Something you can also do is it creates a chat session. Now, this is not unique to remote assistance. A lot of these remote tools like TeamView, AnyDesk, VNC, heck, there's a lot of them. They all have, some sort of chat session. And the reason for that is if you are assisting someone remotely, it allows you and them to chat, in a little chat box. So they can type in a chat box what the problem is. You can see it, they can see it, and you can both see the mouse cursor at the same time. You both see the same screen at the same time. You both have control over the same PC at the same time. It's not like remote desktop, the previous topic, where it kicks the one person off and only one person at a given time can see the desktop and control that PC. No. With remote assistance and all of those other third-party tools I've mentioned, all of them, you can both control the same computer at the exact same time. You can both move the mouse. You can both control the keyboard. You can both do whatever. That's why they've given you a chat session you guys can communicate. So yeah, it controls desktops remotely. And when I say desktops, they obviously include laptops of that as well. Alright guys, so that pretty much concludes the fifth main section, and that's pretty much all for this specific module. If you have any questions about any of these topics, the main sections, the subtopics themselves, you're more welcome to drop that question down below, and I'll gladly get back to any questions you might have. Would it be about the exam, maybe something I didn't cover in enough depth for you, something you would like to cover extra? Feel free to drop those questions down below. And if there's nothing else, guys, please remember to give the video a like so that YouTube can basically push this out to more people that actually need it. And if you yourself would like to know when Module 6 and the rest of the modules comes out, remember to hit that subscribe button. Lastly, folks, just a special shout out and thank you to the sponsors like usual. So, guys, thank you very much for sponsoring the channel. I do appreciate it. And if any of you guys would like to do the same, you can find all of that information in the video description down below. Alright guys, see you in Module 6.
If you love me, let me know. If you don't, then let me